The soil across Western Australia's wheat belt doesn't just fail to grow things, it actively destroys them. Across nearly 2 million hectares of what used to be farmland, the earth has turned white, a hard, crystalline crust of sodium chloride, thick enough to see from orbit. The ground underneath that crust isn't really soil anymore. The clay particles have collapsed into an impermeable slab that won't hold oxygen, won't absorb rain, and can't support a single living root. This isn't contamination from a factory. It isn't runoff from a mine. Beneath every hectare of this landscape, between 100 and 10,000 tons of salt have been sitting in the deep clay for millions of years. The salt was always there, something used to keep it locked underground. That something was removed and the entire system flipped. How does a landscape that supported complex woodland for geological time reach a point where it poisons itself from below? And how do you repair it when the last people who tried, backed by billions of dollars and millions of trees, only made it worse? The fix didn't require desalination plants or engineered drainage. It didn't require pumps or pipelines. It required seeds, specific seeds, matched to specific rainfall, dropped into soil that was trying to kill them. The most advanced technology deployed across this 200-kilometer corridor is a native seed soaked in water that smells like smoke. For millions of years, the Western Australian wheat belt operated as a sealed hydrological system. Dense, multi-layered woodlands of eucalypts, acacias, and native shrubs covered the landscape, their root systems extending as deep as 30 meters into the earth. These plants functioned as a biological pump, drawing water out of the soil and returning it to the atmosphere through their leaves at a rate that nearly perfectly matched the incoming rainfall. Less than 1 millimeter per year slipped past their roots. The water table sat safely at 20 to 30 meters below the surface, and the salt that had been accumulating in the deep clay for geological time stayed buried down there, separated from every living thing by a vast column of dry earth. Between the early 1900s and the 1960s, the Western Australian government ran a clearing program so aggressive it had its own slogan, 1,000,000 acres a year. Across some districts, more than 95% of the native woodland was ripped out and replaced with annual crops: wheat, barley, pasture for sheep. Plants with root systems barely a meter deep. Plants that grew for a few months each winter, then died or went dormant, leaving the ground bare and biologically silent for the rest of the year. The pump that had managed this landscape's water balance for millions of years was switched off. What followed was invisible at first. The shallow crops couldn't intercept all the rainfall, and the excess slipped past their roots and kept going, down into the deep soil, down into the aquifers. Leakage jumped from near zero to between 30 and 60 millimeters per year. Multiply that by millions of hectares and compound it over decades, and you are pouring billions of liters of water into aquifers that were never meant to receive it. The water table began to climb. A farmer standing on his paddock in 1970 wouldn't have noticed anything. The damage was 20 meters below his boots. But monitoring bores tracked it. The water table rising between 1/10 of a meter and close to a meter per year, dissolving the ancient salt deposits as it climbed, transforming from fresh water into concentrated brine. Then it crossed the line. In the wheat belt's soils, there is a critical depth, approximately 2 meters below the surface. Above that mark, gravity stops controlling the water. The microscopic pores in the soil begin acting as a wick, drawing liquid upward, the way a paper towel pulls water from a puddle. Once the rising, salt-saturated water table crossed that 2-meter threshold, the soil itself began pumping toxic brine to the surface against gravity continuously. The sun evaporated the water, the salt crystallized on top. White, blinding crusts spread across paddock after paddock, and there was nothing subtle about this stage. Farmers watched it happen in real time. Ground that grew wheat last season refusing to grow anything this season. Fences corroding, dams turning cloudy. Locals called it the creep. The salt killed whatever vegetation remained, which eliminated the last transpiration, slowing the water table's rise. More water reached the aquifers. The table climbed faster. More salt surfaced, more plants died. The system locked into a self-reinforcing spiral, where each year's damage accelerated the next. The sodium also attacked the clay structure of the soil itself, causing particles to collapse into an impermeable hardpan. The soil wasn't just poisoned, it was structurally dismantled. By the early 2000s, nearly 2 million hectares had been consumed. Projections showed up to 5 million at risk. 850 endemic species faced extinction. The Avon River alone was exporting 1.5 million tons of dissolved salt into the ocean every year. Roads were corroding, foundations were crumbling. What started as a farming problem had become an infrastructure crisis, a biodiversity emergency, and a public health threat rolled into one. The largest environmental disaster in Australian history, and almost nobody outside the country had heard of it. Mechanical fixes, pumping bores, drainage trenches, evaporation basins targeted the symptoms. A single relief well could only lower the water table within roughly 100 meters of the bore. Covering millions of hectares that way was physically impossible. Then came the largest intervention attempt in the region's history. The diagnosis was correct. The landscape was missing its biological pump. The prescription was fatally wrong. In the late 1990s, the Australian government created tax incentives that poured billions of dollars into forestry. Two massive agribusiness companies, Timbercorp and Great Southern Plantations, acquired hundreds of thousands of hectares and planted them with a single species, Eucalyptus globulus, the Tasmanian blue gum. On paper, the logic was clean. The landscape needed trees to lower the water table. Blue gums grow fast and transpire aggressively. A single mature tree can pull 37 liters of water from the soil per day. The species was built for Tasmania's cool, wet coastal forests, where annual rainfall reliably exceeds 600 millimeters. The wheat belt receives 300 to 400. That gap, 200 millimeters of annual rainfall, was the margin between a functioning pump and a death sentence. The blue gums established quickly and began drawing the water table down, which looked like progress. But their transpiration rate was calibrated to a wetter climate. They burned through the available soil moisture faster than the rainfall could replace it. Their roots hit the ironstone hardpan and granite layers that sit less than 2 meters below the surface in much of the wheat belt and couldn't push deeper. Confined to that shallow band of soil, running at full capacity in a climate that couldn't sustain them, the water columns inside their wood physically snapped under the tension, like a drinking straw collapsing under too much suction. On soils less than 2 meters deep, survival plunged to 22%. The trees died standing. When the global financial crisis cut off investor capital in 2008, neither company could service its debt because the trees, the only assets backing the loans, were dead or dying. Timbercorp collapsed in April 2009, carrying $900 million in debt. Great Southern Plantations followed weeks later. Between them, they abandoned over 200,000 hectares of failed plantation and left more than 50,000 retail investors holding worthless loans. The wheat belt had just run the most expensive possible demonstration that identifying the right problem and solving it are two entirely different things. The blue gum wasn't the wrong idea. It was the wrong species, running at the wrong transpiration rate, on the wrong soil depth, in the wrong rainfall zone. A pump rated for 600 millimeters, installed in a landscape that delivers 400. The precision of that mismatch is what made the failure absolute, and what made the correct diagnosis, when it arrived, feel inevitable. Ray Wilson, founding CEO of Carbon Neutral, began acquiring degraded wheat belt land in 2007 with a premise the corporate schemes had never operated under. The land wasn't a timber resource to be harvested, it was a broken machine, and the repair manual was the landscape that had existed before the clearing. The intervention that became the Yarra Yarra Biodiversity Corridor started from a single mechanical insight. The original pump wasn't one species, it was 40 to 60, each drawing water from a different depth, each adapted by millions of years of evolution to survive on less than 400 millimeters of erratic rainfall. The species list reads like a parts manifest for the original machine: York gum, jam wattle, melaleucas, banksias, deep-rooted mallee eucalypts, and on the worst salt scalds, the white, dead ground where nothing else can survive, saltbush. Saltbush is the pioneer. It tolerates salt concentrations that would kill any other plant. It establishes on the toxic crust, pulls water through its roots, and draws down the capillary fringe just enough to sever the wick. As the local salinity drops, less tolerant species move in behind it, acacias at medium depth, mallees pushing their roots deeper. The native mallee eucalypts solve the precise problem that killed the blue gums. They direct vast amounts of their energy underground, building thick woody storage organs and sending taproots that can navigate around the ironstone layers the blue gums couldn't penetrate. When summer drought arrives, mallees close the pores in their leaves, throttle back their water use, and conserve. They are pumps rated for exactly this rainfall. The planting relies on modified direct seeding machinery, heavy equipment that cuts through the hardened salt crust, carving V-shaped micro-catchments that funnel scarce rainfall directly to the seedbed. Into those furrows goes a chaotic mix of dozens of species. Not in rows, not in blocks, but in the tangled, overlapping arrangement that mimics native woodland. One biological lock remains: native Australian seeds have evolved to germinate after fire. Their dormancy is deep, their seed coats hard. Without the chemical signature of a bushfire, they won't sprout. The project bypasses this by soaking the seeds in smoke water, a solution containing the specific molecules released when plant material burns. The seeds register the chemical signal and germinate as if a fire has just swept through, even though the landscape hasn't burned. 35 million native trees and shrubs, 40 to 60 species. 21,000 hectares of restored land within a 50,000 square kilometer management area, building toward a continuous 200-kilometer corridor, reconnecting 12 isolated nature reserves. No irrigation system, no fertilizer, no timber harvest, ever. The pump stays permanently installed. The entire operation is funded through the voluntary carbon market. The Yarra Yarra Biodiversity Corridor was the first project in Australia to achieve gold standard certification, selling verified carbon credits to corporate buyers. The financial model that destroyed Timbercorp rewarded speed. This one rewards permanence. What was being built wasn't a forest in any ornamental sense. It was a hydrological repair, a multi-layered root system designed to pull the water table back below the capillary threshold and hold it there, permanently, on nothing but sunlight and 400 millimeters of annual rain. The same physics that drove the collapse now run in reverse. The cascade started with leakage, 30 to 60 millimeters of water per year slipping past shallow crop roots. Across the reforested zones, the multi-depth root network now intercepts rainfall at every level of the soil column. Deep drainage has been driven back toward the pre-clearing baseline of less than 1 millimeter per year. The cascade's next stage was a rising water table. In monitored reforested sites, the water table has dropped by 1 to 2 meters. That specific measurement is the mechanical hinge of the entire recovery. The capillary threshold in this soil sits at 2 meters. Pushing the water table below that line physically severs the wick. The mechanism that was pumping salt to the surface has stopped. With the capillary connection cut, seasonal rainfall can finally do what it couldn't for decades. It soaks into the ground and slowly flushes the accumulated surface salt back down the profile. Monitoring by Murdoch University has confirmed measurable decreases in salt concentration and a gradual increase in organic matter across the planted corridors. The soil is beginning to function as soil again. That self-reinforcing death spiral is now running in reverse. More plants mean more transpiration. More transpiration pushes the water table lower. A lower water table means less salt at the surface. Less salt means more plants establish. Each year, the system compounds its own recovery. The biological evidence arrived from species no one was expecting. Aerial scanning detected active breeding mounds built by the malleefowl, a threatened bird that constructs massive nests from decaying leaf litter and cannot exist without mature canopy cover. Its presence means the woodland is producing continuous surplus organic matter. Then, motion-sensitive cameras in the Hughes block captured Woolley's false antechinus, a small carnivorous marsupial so rarely observed it lacks a formal conservation status. It was the first recorded sighting of the species anywhere in the wheat belt. A carnivorous marsupial means the entire food web underneath it, soil microbes, invertebrates, small reptiles, has been rebuilt from the ground up. The corridor has sequestered over 1 million tons of carbon dioxide equivalent. Independent valuation places the biodiversity and environmental co-benefits at up to $63 million. More than $8 million has flowed into over 140 local businesses, generating over 200 jobs in a region that was losing both. 35 million seeds soaked in smoke water scattered into furrows cut across poisoned ground. No pumps, no pipelines, no desalination. The same rainfall that was destroying this landscape a generation ago is now powering its recovery. Because the right roots are finally in the ground to catch it. The wheat belt's salinity crisis was caused by removing a pump. The salt was always underground, the water was always falling from the sky. The only thing that kept them from meeting at the surface was a community of plants rooted at the right depths, transpiring at the right rate, running year-round on nothing but sunlight and rain. The fix follows the same logic in reverse. No new chemistry was invented, no drainage infrastructure was engineered. The landscape needed its original pump reinstalled. Not a commercial approximation, not an industrial shortcut, but the exact species, at the exact root depths, calibrated to the exact rainfall. The most advanced technology in this 200-kilometer corridor is a seed.